All right, this is going to be a real quick review just on this topic of parallelograms. All right, so I wasn't technically here on Wednesday, but I did show you the video, and I think I went through everything, enough that you should be able to figure out what was going on. But I figured I'll just I'll go through it one more time, just as a quick review. I won't take as long as I did when I first taught it. Let's go red on this. All right, so here's what we have. We have a parallelogram. So let's spell it correctly first. So how do we spell parallel? There goes two L's, then one L. Everybody see that? So spell it right. And then parallelogram. O-gram. That's the easy part. All right, so parallelogram. So the thing that we're talking about is a parallelogram. It's a four-sided figure. What's just like a general four-sided figure called? What's the name of just anything that's a four-sided figure? Is every four-sided figure a square? Quadrilateral. That's right. A quadrilateral is any four-sided figure at all can be considered a quadrilateral. Not every single figure, four-sided figure, can be called a square. Would you agree? This has got four sides. What would you call that, a square? No. But you can call it a quadrilateral. Any polygon with four sides can be called a quadrilateral. A parallelogram is a specific type of quadrilateral. Okay, it's a special type of four-sided figure. So what's special about it? Well, by the definition, we know that both pairs of opposite sides are parallel to each other. So I'm going to make those two parallel, and I'm going to make these two parallel. That's by the definition. So if somebody said, what is the definition of a parallelogram? You would say it's a quadrilateral with both pairs of opposite sides parallel to each other. Everybody with me so far? All right. So that's a parallelogram. Let's change colors on this one. We also know something else. We know a bunch of stuff about a parallelogram. Let's just fly through it pretty quick, a little faster than what we did when I first taught it. So what else is true about the opposite sides? They're parallel to each other, but they're also what else? You remember from the other day? I got some people doing English and things like that. This is math. Let's concentrate on what we're doing right here. Okay? What do they do? Well, let's just talk about the sides for right now. We'll talk about the angles in a second, but right now let's just talk about the opposite sides. They're equal to each other, aren't they? So the opposite sides are equal to each other. So I could put a tick mark here, tick mark there, and then this would have 2 and this would have 2. All right? So what do we know so far? We know the opposite sides are parallel. We also know the opposite sides are equal to each other in length. Right? The length of this is exactly the same as the length of this. Same thing with these two sides right here. Does that mean all four lengths are equal to each other? No, not necessarily. It just means the two that are opposite each other are equal to each other. And you know what they're going to do with that, right? Don't they do stuff like this? They'll make this like 3x plus 2, and they'll make this like 5x minus 1. Then they say solve for x. Remember that? So what do you do with those two? What if they told you that this length was 3x plus 2 and this one was 5x minus 1? Set them equal, and then just do your algebra and solve for x. Right? And you had a bunch of that kind of stuff on the worksheets, didn't you? Yep. So again, the math wasn't hard. It's just to understand which are equal to each other and which aren't equal to each other and all that kind of stuff. Brianna, you said something. What did you say earlier? Good. The opposite angles are equal. So that's another thing that we know about parallelograms. So this angle right here has got to be equal to this angle right here, if that thing's a parallelogram. Okay, so if it's a parallelogram, the opposite angles are equal. Tell you what, let's label these so we can talk about them. All right, so angle A is equal to angle C. Is that the only angles that are equal to each other? What else, Josh, do you think is equal to each other?
B and D.
B and D, right. So they're opposite angles as well, aren't they? So angle B must equal angle D. Does that mean A and D are necessarily equal to each other? No, just the ones that are completely opposite. You know what I'm talking about by opposite, right? Do you see how they're completely across from each other like this? All right, they are opposite angles, so they're equal. There's something else we know about the angles. Anthony, do you remember anything else? What about like A and D? Is there any kind of relationship between A and D? Brianna, say it. What are they? They add up to 180. Good. Give me good geometry, good solid geometry word for supplementary. Good. Okay. So these two angles right here are supplementary. So here's a big word for you. They say that the consecutive angles are supplementary. What in the world does that mean? It means the angles that are right next to each other. Okay. The ones that are right next to each other. That means consecutive. All right, consecutive means one right after the other. So the angles that are next to each other are all supplementary. So A and D are supplementary. Give me some other angles. Ethan, give me another pair of angles that are supplementary. A and D. What else? D and C. Good. D and C are supplementary. C and what? B. Good. C and B are equal. And what's the last one? A and B are equal to, or not equal. I shouldn't say equal. Are what? Supplementary to each other. Everybody see that? So, for instance, if you knew that this was 80 degrees, angle A, could you tell me the rest of the angles if I only gave you one of them? Ethan, what would you give me? If this was 80, what else would you know? You know, C is 80, right, because their opposite angles are equal. D is what? 100, right. How'd you get 100 out of that? Took it away from 180, right, because they're supplementary. Exactly, that's what supplementary means, right? So that's got to be 100, right, because 180 minus 80 is 100, right? And this has got to be 100. Because it's equal to this. And it's also supplementary to this one, and it's also supplementary to that one, right? So lots of reasons. So if they just tell you one angle, you should be able to figure out the other three. Agreed? All right, very good. Let's see. I think that's it until they start talking about these lines right here. Do you remember what they call these lines if I go from one corner down to the other corner? No. A diagonal, very good. Lauren got that. So the diagonals. And we learned something. Do you remember talking about the diagonals on Wednesday? What do they do? Okay, one is longer than the other. Okay, but a little bit more specific. I told you something in the video on Wednesday, something more specific. Okay, well, they do intersect each other. It's kind of obvious, but they don't just intersect. It's a little more specific than just intersecting. John? At the middle. Okay, they bisect each other. That's the word. That's the word I was looking for. That these diagonals bisect each other. So let's put an E right here so we can label this. So what does that mean if they bisect each other? They split each other, what? In half. Okay? Or into two equal parts. Well, let's not worry about the triangles right now. Let's just worry about the lengths of the sides. So what can I say about AE? I'll put one blue tick mark here. That doesn't mean it's equal to this one, okay? I just don't want to stick 3 and 4 tick marks in there. EC, right. AE and EC would be equal to each other. Because why? Because it's been split in half, right? Split into two equal parts. Agreed? What else could you say was true here? DE. Let's not say D and E. We say what? Line segment DE is equal to line segment what? EB or BE, right. Everybody see that? Okay, and of course they could do this. They could say, all right, AE is 5. What if they told you AE was 5 and they asked you to find what the length of AC is? AC. I'm asking for AC.
Oh, it's...
Which is? 10. Okay, right. All right, so careful what I ask, okay? AC. Now, you know this is 5, so this has to be the same thing, right? But I asked for AC. What would AC be? It would be 10. Make sense? And you know what they're going to do with that, too. Don't they do this kind of stuff? This is like 3x, and this is 2x plus 1 or something like that, right? And then what do? You set them equal to each other, solve for x, and that's basically what they ask you to do, isn't it? All right. I'm trying to think what else they want you to know here. Okay, there is another one. Let's do this. Now, what does that look like to you?
rectangle.
Yeah, it looks like a rectangle. But have we even talked about a rectangle yet?
We don't know it.
No, we don't know what it is, and we don't even know what it, technically, we don't know what a rectangle is, do we? I know you know what a rectangle is, but, okay, 2 sides are equal and the other 2 are equal. Well, that's true about this. Is that a rectangle? No. Now, we have another lesson specifically about a rectangle, so I don't want to get too much into rectangles. So let's not even worry about this being a rectangle or not being a rectangle, okay? But I'm going to do this. Let's say, though, that this is a parallelogram. All right, so what do we know about this thing if it's a parallelogram? Well, we know the opposite sides are parallel. We know the opposite sides are equal. We know the opposite angles are equal. We know the consecutive angles are supplementary, right? So what if I told you this? What if I said, on this parallelogram, one of these angles up here is a right angle, okay? I told you that. Now, you can't just assume it is just because it looks like it, can you? All right, but I told you that's a right angle, and I also told you that this whole thing, we'll call it WXYZ. That whole thing right there is a parallelogram. So Z's got to be 90. How did you know Z was 90? Because it's an opposite angle and it's equal to this, right? It's a parallelogram, opposite angles are equal. Agreed? Not just because it looks like it, but because we had reason to back it up, didn't we? So if this is 90 degrees, tell me something about W. Can I figure out what W is? How do you know it's 90? Because 180 minus 90, exactly. Okay, it's not 90 for the same reason that these two were 90. Would you agree? This was 90 because I told you. This was 90 because opposite angles are equal. This is 90 because consecutive angles are supplementary. You got it? So Y is also what? And then you could use a couple different reasons, couldn't you? You could say it's supplementary to either one of these, or you could say it's opposite this one. Either way, it's still going to be a 90. So guess what? If I had a parallelogram and I told you just one of the angles was 90 degrees, what must be true about the other three angles? They have to all be 90 degrees. Make sense? So if I give you a parallelogram and I told you that this was a parallelogram to begin with, if I told you one of the angles was 90, then all of them have to be 90. And you're right, this is a rectangle. I mean, you know about rectangles since you've been a little kid. But we're going to talk a little bit more specifically about rectangles in a day or two. All right? Not today. So that was one of the theorems in this lesson. All right? I don't know if I did that on Wednesday or not. Sometimes I skip that one. It's just kind of... It's one that almost is kind of common sense, isn't it? And so sometimes I forget to mention it. Let's see. Let's do a couple of... Well, not really examples, but let's look either in the book or in the worksheet. Was there something on the worksheet that bothered you a little bit that you want to go over? Yeah, I think it was. I get accused sometimes, with all my other classes, I get accused sometimes of saying everything that we do is easy. Like, Mr. Hamrick, everything is easy to you, you know? But I think, I'll be honest, I think this was pretty easy, don't you? Yeah, I think you would agree. Is there anything at all? What about like 5 through 8 on page 74? Why don't we look at that? That might have looked a little bit. So let's try that one. I figured you might want to see that one. So that's, parallelogram looks a little bit flatter, about like that. And then they put a couple diagonals in here, don't they? Put one right here and one right here. And let's put some stuff in there. So they put a 25 right here. It's 25 degrees. They say this little one right here is 30 degrees. Now they put a 4b minus 1. What is the 4b minus 1? It's that side, right? It's that left side right there. And on the picture, they put a little arrow with the 30. It looks a little confusing, but if you do it big enough, you can slide in that 30 right where the angle's supposed to be. And that's all they tell you. No, they tell you this is 23, right? And what are my letters? R, S, T, U. So R, S, T, U. And B is in the middle. All right? So let's basically find as much stuff as we possibly can, okay? Say that again? Yeah, good idea. Okay, let's find what B is first, okay? And I think, yeah, they asked for some angles and all that kind of stuff. But, yeah, let's find this right here. 4b minus 1 and the 23. Look, they're opposite each other, aren't they? So what do we know about a parallelogram? The opposite sides are equal to each other. So we can do that pretty easy, can't we? 4b minus 1 equals what? 23. Add a 1 to both sides. 4b is 24. Divide by 4, b is 6. All right, so that's one answer right there. Pretty simple, right? Is there any way I can find RS and UT? Did you say yeah or no? Look at it. Everybody think. Come on, let's think a little bit. Can I find RS or UT if I know these two sides? What? Yeah? What would I do? I'll help you out. You guys are thinking too hard. No, there's no way. I don't know anything about RS. I don't know anything about UT. There's no relationship between this top side and this side. Okay, this one on the side right here. Okay, yeah, there's no relationship, so I can't. I need to know something about at least one of them, right, to be able to figure out what the other one was. So I can't find RS and UT. A little bit of a trick question. All right, but just wanted to get you thinking a little bit. What else do they ask for? Angle RST. Let's find out where RST is. I think some of you guys still have a difficulty understanding what angle they're asking for. So if they said angle RST, where is RST? It's that whole big angle right there. Do you see it? Here's R, here's S, here's T. It covers that whole entire angle right here. Now, how in the world are we going to find that big angle right here? Well, let's do this. Let's find this angle right here. That could be helpful, couldn't it? So what's that whole big angle right there? 55, right? So that whole big angle is 55 degrees. Does that mean this is 55 degrees? No. What's the relationship between them? They're supplementary. So how do I find this one if I know this is 55? Good. You're getting the hang of this, aren't you? So that's what, 125, I think? Yeah. So that big angle right there is 125 degrees. So that's not too bad, is it? You had to do a couple things, right? You had to add them up, then you had to subtract it from 180. All right? So that's RST. They also ask for angle TUR. Angle TUR. Let's find where TUR is. Here's T, here's U, here's R. So there's that big angle right there. Yeah, without doing any math at all. How can I figure this out without doing any math? It's opposite. That's right. It's opposite this angle right here. So that has to be 125 degrees. Right? Without even doing any math, because I already did the math to get that one, right? What is that? The whole big thing? Yeah, the whole big angle T would be 55. And that's what they ask for next, isn't it? It's angle STU is what they call it. So here's S, here's T, here's U, and that's this angle right here. Do I have to do any math to find that? No, I've already done it. I've already figured it out from this. This is 55. That has to be 55. See how easy it is once you find one? Then the rest kind of fall into place. Do they ask for anything else? Nope. That's all they ask for. Right? Pretty easy stuff, isn't it? What if they ask for STB? Angle STB. That would be this little angle right there. 30. Okay, good. It's not, well, you're close. It's not opposite interior. What do we call it? No, not opposite. Alternate interior. But that's what it is. Because look, I've got parallel line. Actually, let's see if I want to find this one. I got parallel lines. I got this one and this one are parallel to each other, right? Because it's a parallelogram. And this is my transversal. If this is 30, then that has to be 30 right there. And of course, this has to be what? 25 for the same reason. Does that make sense? That was a little bit harder to see than the whole thing, but they could very well ask for something like that. Make sense? Let's do one with the diagonals, just so that, because we really didn't do any algebra yet, have we? Let's do I don't know which one. That one's too easy. Let's do number 2. Let's do number 2. And they kind of twist this a little bit. So let's kind of looks it's not exactly that, but let's see. Does that kind of look like it? Not really. Trying to make it. Maybe if I do that. Yeah, it's a little more slanted, but that's okay. It's good enough for us. What do they say? They say this angle is y plus 10. Let's put y plus 10. This may not be to scale, but that's okay. And this one down here is 4x. And this one up here is 2y minus 40. Alright? And we're trying to find x and y. Yeah, exactly. Alright? Everybody see that? Because look at this angle right here. And look at this angle right here. Why did I compare those two to each other? Because they both have y in it, right? I wouldn't do anything with this and this because one has x and one has y. You wouldn't be able to figure anything out from that. And look at it. They're opposite each other, aren't they? So if they're opposite each other, what do we do to them? Set them equal to each other. Exactly right. So let's take that 2y minus 40. and set it equal to y plus 10. And then we just do the math. We've been doing this math all year long, haven't we? This kind of stuff. Would you agree with that? Almost from day one, since we started the geometry portion of this, we've been doing the same exact kind of thing. Either setting things equal to each other or adding them up and setting them equal to something else, right? All year long we've been doing that stuff. It's just we do it with different pictures, right? Different figures. That's the only thing different about the chapters. So let's do this. We subtract a y from each other. So that cancels out. Let's do this in the same step. Let's add a 40 to both sides. Everybody okay with that? 2y minus y is y, and 10 plus 40 is 50. So y is equal to 50. But now what do we have to do? We got to find x. So let's plug it in. Right. So if y is 50, does that mean this angle right here is 50? It's 60 because it's y, which is 50, plus 10, which is what? 60 degrees. So that's this angle right here, 60 degrees. Now, are these equal to each other? No. So what do we do with them, though? We take that 4x and do what to it? Add it to 60, and what should that equal? 180, right? Because these two are supplementary. Subtract 60, we'll do this in our head. Subtract 60, what's that? 120. Divide by 4, and what's that? 30. And there it is. Easy as that. Is that making sense? I kind of like this parallelogram stuff. It's actually, I told my last class this, and I don't say this about every chapter, but this is probably one of my favorite chapters to teach. First of all, because it's easy, and the students usually get it, and that's what I like. Okay, I like it when the students get it, and that makes me happy, and I'm sure it makes you happy too if you get it, doesn't it? Don't you feel much better about this when you actually know what you're doing? Of course, everybody does. All right, and the teacher does as well. So this is usually one of my favorite chapters to teach, just because it's kind of easy to understand. You just have to know a few rules, a few relationships. You got to know the opposite angles are equal. You got to know the consecutive angles are supplementary. You got to know that the diagonals bisect each other. You got to know the opposite sides are equal, right? All that stuff. It's all got to be in your head. You got to know it's true, but once you know all that stuff, the math is pretty simple, as you see right here. We good? All right. So that was a nice review over section 6.2, and plus we got to go over a couple homework problems as well, and that's it. And I think the problems from the book were pretty much just like these worksheet problems, weren't they? So if you know how to do the worksheet, you should have been able to do the book stuff. All right. So I hope that helps a little bit. If you're a little bit lost, maybe hopefully you found your way a little bit on that one. Tomorrow we're going to start with a brand new section. Okay, so we're done with the review, and we're going to do a brand new section, and we'll go from there. Everybody good? We probably won't have a quiz on this week, but we'll probably have a quiz on this early next week. Okay, 6.1 and 6.2. All right. All right, that's it. No homework for tonight, and enjoy your evening.